This is the my third video for BSc third year student. Now our paper number 501 of real analysis. Now we start the new topic. We in the last period we have studied about the function. We have defined the function. Now we are going to define real valued functions. Now here functions word is there, real valued function. What is the real valued function? It's a very simple thing. We have defined function f from a to b. Now we just related with the domain, codomain. Now codomain is b here. Codomain b. If this is r, if this thing is r, means this function will be real valued function. Real valued means what? Value means value of the any elements of the domain is a real number. Then this function is known as the real valued functions. Now we see what are the properties of these real valued functions and how we can write the real valued function. Now it's simple. If we have some function, we can take the two functions f and g are the two real valued functions. Means codomain of each function is r. That is r is what? That is the real numbers. Means if image is the real number, then this function is known as the real valued function. Now f is a function a to r, g is a function from a to r. Then we can define f plus g as a function whose value at this particular point a is equal to f of x plus g of x. Means this is a real number, this is a real number. Now we know that the addition of two real numbers is a real number. So f plus g, this function, the function addition function f plus g at x will be equal to f of x plus g of x, and this is a real number. So the new defined function, that is a plus g, will be also real valued function. What we have proved in this property, that if we have two real valued functions, then the sum function will be addition of these two functions will be nothing but a real valued function. This is proved in the property of this particular real valued function. Now secondly, how to write this thing? It's a very simple thing. We always write a function in the coordinate forms. Why we write in the coordinate forms? Because it's very simple. Every function we have defined the relation. That is, the relation is a subset of Cartesian product of the two sets. Now Cartesian products of which sets? Domain is a set, codomain is r set. Now Cartesian product of two means first element is from the domain and second will be from the codomain. Now here codomain contain the elements. Value sets are f plus g plus g. So we write in this fashion. Now same property can be applied to the first subtraction also, that f minus g can be defined as f of x minus g of x at x. Now these are the two real numbers. We know that subtraction or addition of two real numbers will be again real number. So this value is nothing but will be real number. So we have defined here just f minus g is also a real valued function. Similarly, for the product of two functions, if there are two functions which are real valued functions, now we can say that this product will be also real valued function. This function is defined like this way, f of x plus g of x. Means what? This is a real number, this is a real number. Then product of two real numbers will be a real number, and we have proved that here product function of the two real valued function is again real valued function. Lastly, we prove that if we have g of x, one function which is not zero, means which is not zero means what? Every value of this function is not zero, particularly zero function. This is not zero, this is the zero function actually. And now we can define this thing f by g at x will be f of x plus g of x, means division of two real numbers is a real number only if denominator is zero, then the division is not possible, because we know that any number upon 0 will be equals to be infinity. Then and then only we cannot define this function. Otherwise, this function we are taking f by g function we have defined for the two real valued functions. These are the basic properties, that basic operation, that is plus, minus, product and divisions. Other than these properties, there are some other properties for the real valued function also. We can also verify that properties.